So the most important entity in any class diagram is class itself. To draw a class, you have to draw a box. We will again be discussing the same example that we have been discussing, that is an application to book tennis courts online. So tennis court booking application, right? So the most important class in this application should be member, right? We'll have members. So this is my class name, right? Now you know that every class has certain attributes and it offers certain functionality. So every class will have some data members, right? And it will have some member functions. Data members basically are the attributes of the class, also known as variables or instance variables. And member functions are the functions of the class which offer the functionality, right? When we talk about data members or variables, instance variables of the class, we can have information about them such as data type. Data types could be your primitive data types like integer, string, char, float, etc. The primitive data types, right? Data types could also be your classes or abstract data types, such as, let's say, in our application, we are going to create another class called as booking. So booking is a type, right? You could have a data member of type booking. So it's also a type. Apart from that, certain library classes, for example, in Java, you have string builder. So this could all be your data types, right? The second piece of information we have to denote in our class diagram about data members is access specifiers. They are denoted as, public is denoted as by the sign plus, private by minus, protected as hash, and package as this tilde, right? This is how you denote this access specifiers. Certain modifiers, for example, so you can have data members static, read-only, unique, or array. My first data member, I'll declare it as private. I'll say name of the member. Data type, you have to say colon. Data type will be string, right? This is how you denote your data member. I'll again say private. It will be again of type string, private, address, name of the variable, of type address, where address will be a class which we can write separately. Private, let's say start date, of type date, right? Date is a class. In most of the languages we have date class. If you make data members as private, they can only be accessed within this class. When you make them public, let's say I make start date as public, right? Then those data members could be accessed from within this class, outside this class, by any other class basically. So they are public, right? Then we have something called as protected. When you declare certain data member as protected, that data member can be accessed within this class and within all the immediate children classes of this member class. When you declare certain data member or certain instance variable of type package, right? This data member can be accessed within this class and by all the classes in the same package, right? So you can have one package and you can have n number of classes inside this package, right? Let's say member is one of those classes. Then all these other classes can also, when they create object of member class, they can also access this member count data member of this member class within this class and within all the classes in the same package, right? Static. So you can make certain data members as static. So I'll make this member count variable as static. To denote a static data member is you have to underline it. So this is how you make a certain data member as static. What it means is that this becomes your class level data member. That means all the objects of this member class will share a single instance, a single copy of this static data member count. Read only means they are initialized only once when you are creating the object. Once their value is set, you cannot change the value of those data members. So we'll make start date as read only. Inside those braces, I'll write read only. That once you set the value of this start date variable while you are creating the object, right? That's it. You cannot ever change that value again. It will be read only. You can only read it. You cannot write it again. So that is read only. These are usually denoted by constants in your object-oriented programming languages. Visitors. So every member can bring certain number of visitors while he is registered with our tennis complex, right? And you have to denote like that using a array notation, right? You can specify size or length. If you specify it as star, that means infinite number of values can be there in this array. But if you want to limit this value, limit this size of the array, then you can also specify it like, let's say, suppose 3. So you can say only this size of this array will be 3. So only 3 visitors will be allowed per member. Here, you can also use unique. So you can say that all the values inside this string, inside this visitors array shall be unique. So you can apply this constraint of unique. So we'll say modifiers come constraints. Let's now learn how to denote member functions inside a class diagram. So I've removed certain data members in order to make some space for my member functions. I'll draw a boundary. Right. So this is our boundary between data members and member functions. The first member function that I'm going to write is constructor. Is very simple to draw. Usually constructors are public, right? Unless you are using certain solutions such as singleton pattern where you can make your constructor private. Usually they are public. So I'll say plus. Constructor is basically the same name as that of your class name. So I'll say member. You have to provide the arguments, if any. So I'll say parameter name n of type string, right? Then I'll say email of type string, and then I'll say one date, sdate of type date, right? This is my constructor. Usually for every member function, constructor is a member function, right? You'll have to specify the return type, like colon followed by return type. But in case of constructor, we usually do not denote the return type because you know that constructor always returns the object of same type. Show details. This method will not require any parameters, no parameters, and this method will not return anything. So I'll say void because this is just going to print the details of the members such as name, email, start date, etc. We have this member count, right? So member count will increase every time we create a new object. So we'll write that member count increase code in our constructor, but we need a function which will be able to display the current count. So we'll write a function public get member count. So this method will return the count of total objects of members that have been created till now. This method will not require any parameters and it will return integer, right? So this is the return type, parameter list, name of the function, access specifier, right? Now, because this method is going to access static data member, that is member count, we shall make it static. So this is the way you make a method static. That is by underlining the method. Static methods can only access the static data members. These are called as class level methods. That means you can invoke it like member dot get member count. Like this, I can call it and collect this value and print it, right? Change email, right? This method will require a parameter email, right? So new email, which will be of type string. This method will return a boolean, true or false. That is just to denote whether the changing of email operation has been successful or not, will return true or false. If the change email operation is successful, we'll say true, return true, or false. Let's say somebody is trying to change the email and specify the email which already exists for some other member. Then in that case, we shall not change the email and return false, saying that we cannot change the email and will return false. So now you know how to denote member functions inside your class diagram. Access specifier, function name, parameter list, colon, return type. This is how you denote member functions. Can you see a trend here? Most of our or all of our data members are private, and most of our or all of our member functions are public, right? So this is how you do encapsulation. You keep your data private and you expose the functionality of your class through public member functions. So now we are going to talk about how to denote relationships in your class diagram. For example, inheritance. Earlier we had only one type of members, that is member class. Then we decided to have membership types. We decided to have something called as lifetime members, annual members, in addition to this normal members, right? So now we have one more data member called as end date. This is important for us because this will differentiate annual members, lifetime members, and normal members, right? So I have a constructor, show details method, and I'll also add set duration. We will keep this class and will inherit two classes from this. As these classes inherit from the member class, we'll draw arrow, right, pointing from child class to base class. So the arrow points from the child class to base class or parent class. Because these classes are inheriting from member class, they will get all the data members of this class and all the member functions also. But in order for these classes to be able to modify these data members, will make them protected. You remember protected? Protected data members can be accessed within this class and in the immediate children classes. For lifetime members, we'll set the end date as, let's say, 60 years from the start date. And in annual member, we'll need to set the end date as 1 year from the start date. So for that, we need to override the set duration method in the children classes. Apart from that, these lifetime member and annual member will have another data member called as, so let's say, private booking discount. I want to make this static because it will be same value for all the objects of type lifetime member or annual member. This is basically, we want to give extra booking discount for annual members and lifetime members. Let's say for lifetime members, that discount will be about 50% on each booking. For annual member, it will be about 20% for each booking. So we'll set that, and that value will be shared by all the objects of annual member class and all the objects of lifetime member class. That's why it's a static data member. The constructor will be pretty much the same signature. So I'll just very shortly draw it. It will also need 3 parameters: name n of type string, email, let's say em of type string, sd, that is of type date for start date, right? Now, as I said, we need to override the set duration method. All right, set duration doesn't require any parameter. And now we have this set duration method, which will set the end date based on your start date. In the normal member class, for our normal membership, the start date and end date will be the same date. Whereas we will override this behavior in our lifetime member child class, and we'll say set duration, we'll say end date equal to start date plus some 60 years. Similarly here, we'll also override that behavior. Inside set duration, we'll say end date equal to start date, whatever has been set, plus 1 year, right? So this is method overriding. There's no special syntax. Only thing you have to pay attention is the method signature, the name, parameter list, and return type has to match in the children classes. Now let us learn how to denote abstract classes in your class diagram. We have an entity called as code, right? Of course, tennis complex will have codes, but this code is an abstract class because we have types of code. We have hard code, we have clay code, we have grass code. There's no only code. It has to be either grass code, hard code, or clay code. So we'll make this code class as abstract. The way to denote a class abstract is to write its name in italic manner. We have to write this in italic. And it will have certain methods. For example, we'll say abstract method get rate, and it has to return integer. Remember, the manner to denote an abstract method is also the same. You have to write the entire method signature in italic font. Get info. This also will keep as abstract. It will return the string, the information about the code, right? Now, this is our abstract class, right? So we'll provide the concrete implementation. So these three are the children classes of code abstract class. Because these are concrete classes, their names are not in italic. They are in normal font, right? And inheritance symbol is same, arrow pointing from child class to parent class. Now, we must provide the implementation for this get rate and get info. So we'll just say, again, this cannot be in italic. This is a concrete implementation for this abstract method. We'll write some constructors in these three classes, which will set the value of surface and add some more information about it. So we'll return that information through this getInfo method. Cool. So this is how you denote abstract methods and classes in italic font. Now we will learn how to denote interfaces in our class diagram. We have different modes of payment for the members. So members can pay using credit card or debit card. Members can use net banking. But as a organization, we will still require certain basic information about the payment, whether it be card payment or net banking. We need to have certain standard, because tomorrow we can also introduce few more different kinds of payment methods. But we need to have certain basic information about each payment. For example, amount that has been paid, the transaction ID for that payment, and the transaction entity, who is the organization through which the transaction was made. So in order to have that standard behavior in each different kind of payment mechanism, we will define an interface. Interface keyword here, like this, and we'll have to specify the name of the interface. So in this case, it will be payment info. Let's say, see. Now in this interface, we'll have a method. So have a look at this method signature. It's public. Save payment info is the method name. It requires three parameters. One, that is amount, float, transaction ID, string, and transaction entity, again string, and it returns nothing, so return type is void. Now these different payment methods will implement this interface. So how do we denote that? It is very similar to that of inheritance, just a dotted arrow, and again from children to parents. So dotted arrow from implementing class to interface, like this. And of course, these classes will have to implement that method with the exact signature, right? Transaction entity, right? So I'll just mention it in short, but it will be exactly same signature as that of your interface. Here also we'll have to implement that same exact return type and same exact signature. Let's say amount, transaction ID, and transaction entity. So this is how you denote interfaces in class diagram. Inheritance is a kind of relationship. Let's say class fruit is inherited by banana and let's say mango. So then you say banana is a fruit, mango is a fruit. So inheritance is a kind of relationship. We also have has a kind of relationship. In class diagram, you can denote this relationship in two ways. Booking will be done by member. So say booking has a member M, a data member of type member. And booking will also need some kind of payment. So say payment P, right? So this booking class contains an instance of type member and an instance of type payment. Booking has a member, booking has a payment. But there is a slight difference. We delete this booking instance. Whatever booking object we had created, we delete that booking instance. So with that, the contained payment object will also be deleted because it is a composition relationship. So there is this filled diamond. Booking and payment have a composition relationship because booking has a payment, but when you delete the booking, payment instance will also be deleted with it. So it is a composition. Whereas you created a booking object. So obviously it will require one member instance like payment. But if you delete that booking object, do you expect your member object also to get deleted? No. Member should remain as it is, even if you delete that booking containing that member, right? So this is another has a relationship called as aggregation, and we denote it as like this. Another diamond, but this time the diamond is not filled. So this is called as aggregation. This is aggregation and this is composition. Apart from inheritance, interfaces, composition and aggregation, we also have certain associations between the classes in your class diagram. So let's say we have a booking class and we have a member class. So these associations are denoted by straight lines. So you have to draw a straight line. There's no arrow or diamond. A booking is done by a member. So you'll write, say, done by, you can write it, a member, right? Or a member can do 0 or more bookings. So you'll denote it as 0 ... star. So a member can do 0 or more bookings. A booking can be done by one member. So this is called as bi-directional association because both the entities are involved in the association. A notification is sent to one or more members, but members cannot send notifications or they do not create notifications in the system. So this is unidirectional association. A notification is sent to one or more members. Right? So that is the example of unidirectional association. Now let's look at the example of reflexive association. So in our application, we have a functionality of referrals. Basically, one member can refer new members, right? So this is our member class. Now members are referring other members, right? So it's an association between same entity, right? A member is referred by one member and member can refer 0 or more members, right? So this is an example of reflexive association because it is an association between a single entity.